noise from people. So Crater Lake formed from the eruption of Mount Mazama. You've got this beautiful round, lake. It's just a stunning blue. It's most of it is from snow melt. My students always like to ask me if there's fish in it, and they do have it stocked with fish, and most of the water came from snow melt. It's one of the deepest, purest lakes in the world. And then it's got this really cool cinder cone volcano inside the caldera. Of course, Crater Lake's the caldera of the collapsed crater of the original volcano Mount Mazama. And then sometime after that original eruption, there's still magma under there. And this small cinder cone volcano formed inside the lake. And they call it Wizard Island because it looks like a wizard hat. And it's got a little crater on the top. If you go there in the summer, they have boats that you can take out and walk around on Wizard Island. And then you can also hike down to the lake. It's a quite steep hike, and you can hike down and look at the lake right next to it. So that's really interesting. Some other features in this park: there's a pumice plain with a thick blanket of ash near the north rim. It's still devoid of vegetation 7,700 years after the eruption. So that was a very thick blanket of ash that was left there from that huge eruption. The pinnacles are something you can visit there. It's an area of tall spires southeast of the rim, and those are welded tuff deposits. Tuff are, deposits of hot ash that weld itself together. And then I already showed you Wizard Island, which is a cinder cone volcano. It resembles a wizard hat. It formed in the caldera from eruptions that were later followed the Mount Mazama collapse. And then the phantom ship is the remnant of a volcano that existed before Mount Mazama.
I have a question.
Yes.
Where did the water come from in Crater Lake? Was it all rainwater or groundwater seepage?
It was mostly snow melt, but there's some rainwater too. Yeah, it mostly is from snow melt. And that's the surface. If you hike down to the surface, it's very cold because it's snow melt. There's a lot of snow in this park. The first time I visited it there, we were there in the summer. It was in early June, and we had our kids with us. They were younger at that time, and of course, kids being from Florida, and piled up along the sides of the road. They had plowed the roads. The snow was probably 15, 20 feet high in some areas. And our kids were amazed at that. They had never seen that much snow being from Florida. They thought it was really fun, to just, even though it was old, kind of dirty snow from months before that, they thought it was fun to walk in it and slide on it and everything. So, and that was in June. So in the winter time, I think this park's pretty inaccessible because they have so much snow. And so that's where the water came from, the snow melt. That's another view of Wizard Island. And again, the only times I've been there has been in the summer, and there's still snow even in the summer. That's the pumice plain. And again, you think that was, almost 8,000 years ago that eruption occurred, but you still don't really have it, it hasn't, the vegetation hasn't all come back yet. Okay, we're going to go a little bit farther north now into Washington State and go to Mount St. Helens National Monument. Mount St. Helens is another composite cone volcano, and it's the youngest and most active volcano in the Cascades. And of course, I'm sure everybody remembers the explosive eruption on May 18th, 1980 that killed 57 people. It's now a national monument set aside. It was set aside in 1982 to preserve, study, and explain the eruption and its aftermath. So that's a USGS, United States Geological Society picture. You can see the Cascade Mountains are covered with glaciers. They're covered with snow and ice. This is the dome. You can't see it very well, but the dome volcano that's formed in the caldera since. And then this is part of the Lahar. When Mount St. Helens erupted, again, all of that, or a lot of that snow and ice and glaciers that were on top melted, mixed with the volcanic material, and then all the meltwater mixed with a lot of the ash, because this eruption had a lot of ash. It was a very explosive eruption and created that huge, ash flow, Lahar, which is what killed most of the people that got in the way. It covered, large areas. There was a whole lodge that was there it was a national forest, I think, at the time, and there was a beautiful lodge that people liked to stay in. They tried to evacuate the area, but some people refused to evacuate. There was an old man named Harry Truman, no relation to the president, who owned the lodge, and he refused to evacuate. And apparently he had a lot of cats, a lot of pet cats, and he and his cats and his lodge are now buried under, thick layer of the ash. So, if you didn't evacuate, that was a lot of the people that died. It buried everything in the way, buildings, cars, things like that. This is a cross section of the volcano. So again, you can see these type of volcanoes sometimes erupt explosively with ash and some lava, but mostly ash. And other times they just have lava flows. So that's the characteristic of these strata or composite cone volcanoes. If you make a cross section of them, you have alternating layers of ash and lava. And there's actually Mount St. Helens has a lava tube called Ape Cave, and you can actually hike through that if you go to visit Mount St. Helens. So in the past, it has had, lava eruptions. It's just that the most recent one was the the explosive eruption in 1980. And this is a picture pre-1980. This is Mount St. Helens in the foreground, and it looked a lot like Mount Rainier in the background. So that's Mount Rainier, this is Mount St. Helens. And they were very similar back then, but after the 1980 eruption, it lost its top third of the volcano. So again, from this view, you can really see all of the glaciers and the, that melted and mixed with the hot ash and formed that lahar that came down and devastated a lot of the area around here. Fortunately, Mount St. Helens was not a very populated area. It had a lot of national forest land around there. So it wasn't, it killed 57 people. They evacuated a lot of areas. They knew it was going to erupt. They don't know exactly when, but they knew there was earthquakes and there was seismic activity. And so they knew that something was coming. So they talked a lot of people into evacuating. Some people were there. One of the people that was killed was a geologist. His name was Dave Johnston, and he was on a ridge, and he was studying the volcano and monitoring the seismic activity, and he was killed by the explosion in the Lahar. The visitor center there now is named after him. So he was one of the people that were killed, along with the man with the lodge and some other people that just couldn't get away and didn't evacuate. But now if you look back here at Mount Rainier is considered to be America's most dangerous volcano, because it's not like Mount St. Helens, which is mostly, rural and, national forest. Mount Rainier overlooks Seattle and Tacoma. And so if you'd have this, and it could also erupt, it's still considered an active volcano. If that one were to erupt, you'd have lots more death and destruction than what happened with Mount St. Helens. So they watched Mount Rainier very closely. So this is a before and after photograph of Mount St. Helens before, how beautiful it was. That was the beautiful lake that had the lodge, and people would go there for vacation. And then that's what it looked like afterwards. And right now there's a volcanic dome growing in the caldera. So it is still active. I think they have a camera on it. You can look it up online and you can just go and watch it. And they even have a time-lapse photo you can look up to see how it's grown. It's kind of interesting. Okay, so we're going to move over now to Mount Rainier National Park in Washington. Mount Rainier is another composite cone or stratovolcano. And again, like I just mentioned, it's considered America's most dangerous volcano because it is, it's part of the Ring of Fire, and because it is near Seattle and Tacoma, and they would have many more people to evacuate. And if you've been there, you know, it overlooks, you know, all of these very populated areas. When you fly into Seattle, on a clear day, it's a really, you know, stunning sight to see the beautiful, you know, volcano with all the glaciers on top. But it would be very dangerous if it erupted. And again, it's formed by that subduction of that Juan de Fuca plate beneath the North American plate. And again, I won't try to until I figure out how to get that to show on my screen. I'll have to work with that more. The reason I can't show videos this week easily is because Zoom has taken down the feature where you can share files, and that's how I was sharing mine last week. They've taken that down for security reasons, so I guess, you know, bad people were getting into people's files. So it's the same way with my TCC classes. I now have to share it from my desktop, and so I'm going to have to figure out how to get the videos to show. They show to me, so I didn't know that they don't show, but I'll work on that by next week and figure that out. I'm not sure what to click, and I don't like to do that when I'm in the middle of teaching. So there's Mount Rainier from the air, and like I took this on a flight when we were flying in sometime there. So there's the clouds, and then you can see the beautiful glaciers on top. We will talk about glacier parks one of these weeks, one of these series. So we'll be learning more about glaciers. But Mount Rainier is a very beautiful site and very dangerous. Mount Rainier, 90% of the eruptions from Mount Rainier have been in the form of lava flows, and that's kind of unusual for a composite cone volcano. It's usually more like half and half, but they have gotten mostly lava flows, but it could have an explosive eruption, and the explosive eruption would be much more dangerous. Rainier has 26 glaciers on the top on its steep slopes. And so it poses major hazards to a large population, and not so much from the actual eruption itself, but from the lahars and the debris flows. That's what would cause the most destruction and death. So this volcano, again, considered America's most dangerous, so it's continuously monitored, and it last erupted 150 years ago, which is like, you know, a second ago in geologic time or less. So very recent geologically. And then that's a cross section of it, and you know, see the magma chamber, and you know, it's got a vent, but they also have, you know, it's got a crater or caldera, but they also have vents on the side. And again, if it were to erupt, you'd get an ash cloud, you'd get acid rain. It would be a very bad, you know, very bad thing for the area, plus the lahars and the debris flows. And Mount Rainier is in close proximity to the Seattle and Tacoma region. So I mean, if you're there, I mean, you go into the national park and there's towns all right around, you know, at the base of the volcano. Has beautiful wildflowers if you go in the summer, and it's an absolutely beautiful place to hike. So it is really a nice park. Okay, we're going to go a little bit more north in the Ring of Fire, and we're going to go up to Alaska. Now, all of these parks that I've just talked about, I've been to, and I have been to Alaska twice, but I have not been to Katmai National Park and Preserve. I would really like to go. It is very hard to get to. We went to Alaska once on a cruise where we took excursions, and then the second time we went, we drove, but you can't drive into Katmai. You either have to take a boat or a plane to get there. It's part of the Alaska Aleutian Volcanic Belt subduction zone. And again, so it's still part of the Ring of Fire. In June of 1912, one of the volcanoes there called Novarupta erupted very violently. There's also, Katmai is also a volcano, and the eruption was originally believed to come from Katmai, but when they studied it more, they found out that the 1912 eruption was Novarupta. This was the largest eruption of the 20th century, and it produced a huge amount of pyroclastic material and triggered the actual collapse of the Katmai material because of the volcano, because I guess they share a magma chamber. And so it triggered the collapse of that and formed a huge caldera when the magma chamber emptied. And this occurred, but this is not a populated area. So there weren't like people there studying it, and they mostly had to study it afterwards, because this is a very remote area. So some of the features there are the Valley of 10,000 Smokes, and it's an area filled with pumice and ash deposits. The steam activity, it really isn't still smoking. That stopped in the 1930s, but it gotten the name there from people that had visited, fairly shortly after the eruption. And it, again, is very, very viscous magma, and viscous magma is very high in silica and, low in iron and magnesium, high in silica, and the silica content is one of the things that gives it its very high viscosity. So it's very difficult for it to flow out, and so they tend to explode. And again, that was the largest eruption of the 20th century. Luckily, it was in a very remote area, and they've got a dome volcano now that has formed in the collapsed caldera. The word rhyolitic rhyolite is a type of igneous rock that comes from is a very highly silica, high silica igneous rock, and it's pretty much the same composition as granite. It's just fine grained. It comes from granitic type lava rather than magma, so it cooled rapidly. Now, the reason most people, like if I went to Katmai National Park, I'd be very interested in seeing the volcanoes and the geology. I would also like the bears, but most people don't go there for the geology. They go there for the bears, and it's the premier brown bear viewing area of the world. And the few people that I've known that have been there have actually gone there to see the bears, and that's supposed to be really interesting and cool. This is the Valley of 10,000 Smokes, which again is very remote. I think if you visit and you want to see that, you have to fly over it with a helicopter. And that's some of the ash deposits in the Valley of 10,000 Smokes. So now there's a thick pumice type ash deposits. And then this is a really good picture of a dome volcano. And that's the rhyolitic dome that has formed in the caldera of the Novarupta volcano. And that was the one that, erupted in was that 1930 or whenever that was, early 1900s. Okay, so now we're going to move on. We're out of the Ring of Fire, and we're moving into the middle part of the Pacific to Hawaii Volcanoes National Park. So we're going to Hawaii. So the tectonic setting is different here. We're not at a subduction zone anymore.
Excuse me, I got another question.
Oh, go ahead.
Can you talk a little bit more about how the dome forms and like, is it like crusted over lava or?
Yes.
Actually what it is?
So hopefully everybody heard that. He asked about how the rhyolitic dome forms, and it is very thick, highly viscous magma that's oozing up from the magma chamber, and it crusts over at the top, but it's still hot in the bottom, and it's kind of oozing up and getting larger and larger. And so that's something that, again, that could explode at some time in the future. Did I answer your question? I don't know.
Yeah, yes. Yes, keep going. You're doing very good. Good job.
Thank you. It's nice to hear from somebody. It's good to know somebody's listening. Okay. So we've moved tectonic settings now. When we're, when we go to Hawaii, we're now in the middle of the Pacific Ocean. So we're not on the Ring of Fire. So this seems like a kind of an odd thing. It's an anomaly. Why would we have volcanoes there? It's in the middle of a plate. Well, we do get volcanoes sometimes in the middle of tectonic plates. And this happens when we have an area called a hot spot. And a hot spot is a weak area in the mantle where magma gets moved up closer to the surface and kind of leaks out. And as the tectonic plate moves over the hot spot, it forms a chain of volcanoes. So the Pacific plate is migrating over the hot spot in the mantle, and it produces, again, this is the exact opposite of what we were just talking about in the, the rhyolitic dome, which is a highly viscous magma that's very difficult to flow out. So it forms that, that thick dome that just builds up. This is a very fluid magma or lava. So it's low in silica. It's high in iron and magnesium. So you've got the basaltic composition of lava that tends to just flow out and build these huge shield volcanic structures. And currently, the island of Hawaii sits right over the hot spot. And so that's why Hawaii has the active volcanoes. If you visit the island chain of Hawaii and you go you fly into Honolulu, where you usually would fly in first, and you get to go to, the Diamond Head and look at some of the different volcanoes there. Those are, extinct volcanoes. That island has already passed over the hot spot. Those volcanoes are not erupting anymore. They are dead and they're just eroding away. But the island of Hawaii, the volcanoes are still, some of the volcanoes are still active. And so, because it's still right over the hot spot. And a little bit beyond the island of Hawaii, I guess a little south of that, is a new volcano forming. It has not come up above sea level yet. It's called Loihi, and it's being born right south of the Big Island. Eventually, the Big Island is going to move off the hot spot. Loihi will continue to grow, and it will eventually become the next Hawaiian island, not in our lifetimes, but in maybe 100,000 years or so, which is nothing in geologic time. So this is the island chain of Hawaii. And again, it has moved, the Pacific plate is moving north. The hot spot is somewhere around here now. And so the Big Island is still growing because it's got active volcanoes, and it has moved north this way. So if you age date the lava and on the different islands, the oldest one is up here at Kauai, and then it gets progressively younger. There's Oahu, and then Molokai and Maui, and then the youngest lava. And you can very accurately age date lava, because you can age date it using radiometric dating very accurately. So they have, they have done that, and it's, progressively younger as you get towards the Big Island. And then down here under the ocean is forming the next Hawaiian island, Loihi. Yes.
This seems like it's moving south rather than north.
No, it's moving north. Let me go back, because this used to be here. Kauai used to be here. And the plate is moving north and carrying these north. So these used to be down here, and it's moved this way. And if you actually go even farther north, there's the Midway Islands. They're off the map, but those actually at one time were over the hot spot. So everything's kind of moving this way. So eventually this Big Island will move up here, and Loihi will be here. So the Pacific plate is moving north over the hot spot, which is down here. Did I make that more clear?
No, I don't see that. Go ahead. That's okay.
I'll have more pictures. Maybe that'll make it better. So this is the northwest direction here. Here's the hot spot. and here are your islands. That's southeast, that's northwest. So, and these are the ages of they've written the ages on here. So there's Kauai and this other one that I don't know how to pronounce, Nihau or whatever. Those are, 4.9 to 5.6 million years old. Oahu's 3.4, and then Molokai 1.8, Maui 1.3, and then the Hawaii, the Big Island, so this has all moved north over that hot spot. So these 4 to 5 million years ago, Kauai was here, and then 3 million years ago, Oahu was here, 1.8, Molokai was here, Maui was here about 1.3, and they've all moved off the hot spot. So their volcanoes have died, and now Hawaii's here, and Loihi is over here. So on the southeast portion of the Big Island, Mauna Loa and Kilauea are the only two volcanoes that are still active. Even part of the Big Island has already moved off over the hot spot. This is a picture from the visitor center. This is I've been here also. So this is a hot spot. This is the picture of the hot spot. This is moving north, and this shows you how the islands have moved. The other islands have moved off the hot spot. So, and if you're at the visitor center, you're here. And then this shows the Big Island of Hawaii, and it's composed of 5 shield volcanoes. It's the largest island, and so it's Mauna Loa and Kilauea are the 2 active ones, and then Mauna Kea. Mauna Kea is interesting because you can go up on the top, and they have lots of countries and places in the world have telescopes up on the top here, and they do a lot of astronomy studies because it's very high and it's very clear. And Mauna Kea is also interesting because it's got the only snow removal equipment in the island of Hawaii, because it's very cold when you go up on the top there. And then Walali and I don't know how to pronounce all these other ones, but there's 5 shield volcanoes. There's Hilo, and there's the Kona, the 2 sides, if you've ever been there, been to those two big towns on the island. And this is where the national park is. And Kilauea and Mauna Loa, again, are the 2 active volcanoes. And then if you go down here, underneath the ocean is Loihi. Okay. Oh, it's not moving. Okay. Oops, that's the wrong way. All right. So again, there's your volcanoes. Kilauea, Mauna Loa are the 2 active ones, and then Mauna Kea, the big mountain with the telescopes, the big volcano with the telescopes, and these 2 smaller ones, Hualale and Kohala, are the other 2. And these 3 here are not active anymore. It's just Mauna Loa and Kilauea. Kilauea is the most active volcano on Earth. It's been erupting pretty much continuously since 1980. And so again, Hawaiian Island is made up of 5 shield volcanoes, and Kilauea is the youngest, Mauna Loa and Kilauea, and they're still active. And the lava types, 2 types of lava, and they've gotten their name from the Hawaiian words because they've actually been studied here. There's 2 types, pahoehoe and a'a lava. The pahoehoe lava is the smooth, ropey kind, and the a'a is the rough, blocky kind. And I always tell my students, if you want to remember those, if you think about if you're walking on them, if you walked on the a'a lava, it would be out, it would hurt, and you'd probably going ow, ow, it would hurt your feet. It's very rough to walk on, whereas the pahoehoe is smooth. They also have lava fountains that erupt, particularly on Kilauea, and they produce neat kind of features, lacy lava called scoria, and then little rocks they call Pele's tears and Pele's hair. Have some pictures. They have a lot of lava tubes. Hawaii's another place you can hike through some of the cool lava tubes and tunnels. And they actually have one of the only ways you can get kind of fossils from igneous rocks. They have some lava tree molds and lava trees where the hot lava flows over the tree and then gets cooled very rapidly, and it retains the shape of the tree. Like I said, this is an active volcano, so it actually erupted and engulfed the original visitor center in the national park in 1989. It was covered by a lava flow. They have a nice new one built since then, so you can still go to the nice visitor center. These are lava trees near Kilauea, and again, you can see the, it retains the shape of the tree because the water in the tree cools the lava rapidly. And so you can see like the remains of the tree. That's some other lava trees. That's when I was there. That's my son for scale. I always tell my students, and I hope I didn't say this last week, but when regular people go on vacation, they take pictures of their family and friends by all the, cool sights that you see. When geologists, and my husband's a geologist too, when geologists go on vacation, we make our family and friends get in pictures for scale. So our kids grew up being scale for our geology pictures on vacation. So that's my son. He wasn't looking at me, but he's scale for the lava trees that we have.
And he was shorter then.
Yes, he was shorter then, yeah. And now that we don't take our kids anymore, Joe and I have to be the scale in pictures. So our kids don't go with us usually anymore. Darn. So this is Mauna Loa from the air. And you can really, this is the largest volcanic structure on Earth. And like I tried to show before, it is actually mostly below sea level. So, when you're standing on it and looking at it, it's not that impressive because you can't really see it all. Even from the air, it's impressive, but you can't see the whole structure because it's underneath, the water. There's a really neat video, which is long, but it's called Drain the Oceans. And they virtually drain the oceans from all around the world. And you can kind of see all the geologic features under the ocean. So if you're ever, have nothing else to watch and you're looking for something, I'm sure that's on YouTube or you can find it. I believe it's called Drain the Oceans. And you can see what the ocean ridges look like and the trenches and then the volcanoes. And I think they show draining it around the Hawaiian island chain and what it looks like. It's really interesting. These are some pictures from the National Park Visitor Center. And this is Mauna Loa, which is again the Earth's largest volcano, and it's kind of showing you the scale compared with other structures, and here's Mauna Loa, there's sea level, and of course Mauna Loa goes all the way down, I guess below even the picture, to the ocean floor, and so its scale is just enormous compared to other mountains that they superimpose, like Mount Fuji, Mount St. Helens, and that's just superimposing it on the part that you can see above sea level, and it goes all the way down. So it's really huge. And then if you go to Hawaii, like I said, Kilauea is always erupting. They don't let you walk right up to the eruption. It's usually, it's making the island bigger, but you can often, they have helicopters you can fly over and see the actual lava coming out and erupting. And that's, I think the crater is called.
I'd like to make a comment.
Pardon me? Go ahead.
I would like to make a comment.
Go ahead.
I had heard that Mauna Loa, if you measured the mountain from the seafloor to the top, would be the tallest mountain in the world. But they don't measure mountains.
Right.
That
Oh,
way.
it would. It dwarfs everything else. That's absolutely right. Yeah. They don't measure them though. They only measure them from sea level. But yeah, it's the largest volcanic structure on Earth, and I'm sure the largest mountain on Earth if you take it from the seafloor. Yeah, absolutely. So this is the crater. I think the crater is called Pu'u'o, and that's the crater for Kilauea. And there, you can kind of see the lava flows coming out of it. And again, that's a basaltic lava flow. When it's still liquid, and this is creating that ropey type, or the ropey lava, the pahoehoe. And this is a hike that we took when we were there. It was a lava flow that occurred in 1959, so it's all grown over with vegetation. I love the little ferns, and I really took this because I thought it was very neat. It's shaped like a heart. It's an area where the rock broke out and it's heart shaped. So I thought that was cool. And then that's the same hike where you're, you know, it's not grown, the vegetation has not grown over here, and you can just really see the extent of just that 1959 lava flow. And again, that's my son Greg for scale, and this is it's still steaming. This lava flow occurred in 1959, but he's putting his hand over the steam vent. It's hot there, and you know, you're walking along and there's all these places where it's still steaming, which is really cool. And then there is some plants growing there. So you can take some really nice hikes in Hawaii Volcano National Park and see some really interesting, you know, plants, and you know, and life still comes in these areas where you think, you know, how could anything grow there? But it does. And then this is from the visitor center. These are some of the different like features you get from the different types of lava that come out. That's the Pele's hair, the threads of lava, and that's the little rocks, Pele's tears, types of pyroclastics or rock fragments that come out. Now I will stop here and I'll try to figure out, so maybe we can start with the videos next week if I can figure out how to get them to show on my computer. I'm sure I can. I figured out a lot of stuff with Zoom. So I will end here and we'll start with this. We'll finish up with Hawaii next week, and then we'll also talk about Yosemite. And then I believe the next parks are the ones with surface features, like from water, like the Grand Canyon and the Colorado Plateau parks. So does anybody have any questions? I'm going to stop sharing. I'm going to be on again. Looks like a lot of people stayed, or most people stayed. Yay, good. That's good to see. Thanks so much for participating. If you have any other questions or suggestions, you can email me. If you have any friends that want to, you know, take the class, they can email me and I'll add them in. Is there anybody that wants to say anything or ask anything? And
I've got a couple of questions.
Okay.
Me too.
How do I view the first class that you had last week that I missed?
It did not.
Oh, I did not record?
The
Okay.
recording didn't work. The
Okay.
recording is very touchy with Zoom.
Yeah.
I've heard a lot of other people having problems with it too. So I will try to send out the PowerPoint. I can't send it from my home computer, but I'll try to figure out how to send that out.
Yeah.
Okay.
And the second question was, can we invite, I have a friend that is interested in volcanoes and geology, but she lives in close to Pensacola.
Oh, anybody anywhere can do this. It's virtual.
Okay, so, okay.
Yeah. Yeah.
Well,
Yes.
okay,
Sure.
right, thank you. Great
Sure.
job. I very much enjoyed it.
Thank
Another
you.
question, if you have
Yeah,
time
just
for
a
it.
Yeah, I have time. Go ahead.
Okay, you mentioned several times the relationship between viscous lava and silicon versus flowing lava and rich with iron and other minerals. Why is that? Is one causing the other? Is the heat the reason that only silica is or that silica is not in the other?
Silica melts, the iron magnesium lava is hotter, and the silica is a cooler lava.
So the heat
So
determines the chemical
and also
content.
the composition too. The chemical composition also determines the viscosity.
So
at the temperature and the composition.
okay, so there is differences in composition even in the molten lava
Oh,
before
yeah.
it comes up. Okay.
Absolutely. And the Hawaii volcano, the oceanic material tends to be more of the iron and magnesium composition, and the continental volcanoes that you get on the continent, like the Cascades, tend to have more of the high silica, and that's why they tend to be more explosive, because the continental rocks have more silica in them. They're more granitic. The oceanic rocks have more basalt in them.
Okay, thank you.
Does that make sense? I hope so.
Yes, thanks.
Penny Young, just a couple of comments about the Big Island. I was there last year after the eruption of the previous year. And 30 years ago, when I went to the Big Island, we flew over in a helicopter and saw the magma coming up right there under the earth, and red hot and just amazing. And last year, as we drove down to the beach in one direction, we saw the steam rising on either side of us
Oh, wow.
along the streams or whatever they were, but they were, I guess, the steam coming up from a still, I guess, active volcano.
That's
So
really cool.
I just wanted to comment on that. Yeah. Thank you so much. This was so interesting. So
Well, I'm glad to hear that. I love your feedback, because it's so weird teaching from your house when you really can't see anybody and you don't know if people are falling asleep or whatever.
oh, no, absolutely not.
I just wanted to say thank you before I sign off. This was great.
Okay, well, I'm glad you enjoyed it. Hope to see you all next week.
I'll be there.
All right, thank you. Okay.
Bye.
Thank you.
Thanks. And I'm going to take a screenshot of the suggestions so I can try to figure this out. Let's see. Okay, thanks so much. I'm going to end the meeting in a second. I'm going to take a picture of the screen so I can see if I can figure out what to do. All right. All right. Thanks so much. Thanks, everybody.
Thank you. Have a good week. Be safe.
Yeah, you too. Stay well, everybody. I'm landing the meeting. Bye.
Bye.